All right, these are the notes for what is called similar right triangles. We are going to do what's called the geometric mean and something called the altitude theorem, where you will use the geometric mean. So we are getting into the next topic here of triangles that are congruent, similar, and different things like that. So we are going to do first what's called geometric mean. Geometric mean of two positive numbers, a and b, is the positive number x such that this is a proportion here. So what you have is a and b diagonal from each other and x diagonal from each other. So this is basically a proportion, all right? How do you do proportions? You basically cross multiply, all right? So when you guys were in middle school, you just did the regular mean. You would add up a bunch of numbers, and if there were 5 numbers, you'd add them up and divide by 5. This is called geometric mean. It's a little bit different. So what we do here, I'm only going to give you 2 numbers. You will multiply those 2 numbers, and essentially you're going to take the square root. So that's what this formula here means. So if I say find the geometric mean of 8 and 18, you can set it up like a proportion, which is what I recommend because that's what you're going to do next here in a minute. But when you make the proportion, always put x and x diagonal from each other. All right, then the 2 numbers that I give you, 8 and 18, put them diagonal from each other. How do you do geometric mean? You just cross multiply. X times x is always x squared equals 18 times 8. Now, 18 times 8, you can use your calculator. Make sure you're bringing your calculators to school because we're going to do more practice problems when you do come back into school. 18 times 8 is 144. And again, what gets rid of a square? A square root. If I square root the left, I got to square root the right. Now, sometimes these square roots come out perfect. Sometimes you got to simplify them, but we've already simplified radicals, so we'll have to review that again. So a square root and a square cancel. You just have x. The square root of 144 is 12 because 12 times 12 is 144. So there's your answer right there. All right. Now, looking at these examples, find the geometric mean of 36 and 128. Okay, so I'm going to do my proportion. And it does not matter. You could put x first, but as long as if you put x at the top left, he also needs to be bottom right. Then put the other 2 numbers. There you go. X times x is x squared. And again, you can use your calculator on this. But 36 times 128 is 4,608. How do you get rid of a square? You square root it. Now again, you can type that in on your calculator, but it's not going to come out perfect. So let's just review real quick. How could I break down 4,608? Well, why not use the exact same 2 numbers you just multiplied by? 36 and 128. Remember, why do I like 36? It's a pair of 6s. I'm done. 28, remember you could use your calculator. Y equals 128 divided by x. But 64 and 2. 2 is prime. Circle it. Why do we like 64? I can get a pair of 8s. I don't need to break it down anymore. Remember, with radicals, you get 2 of a kind, you get out of the house. So I have a pair of 6s on the outside. I got a pair of 8, so 8 goes on the outside. The single 2 is on the inside, but what do I do with these 2 numbers on the outside? I multiply them. So 6 times 8 is 48, so my answer is 48 radical 2. Now, sometimes they come out perfect and you don't really have to simplify them. Sometimes they don't. All right, look at this next example. Find the geometric mean of 9 and 25. So same thing. This time let's put 9 and 25 first. Well, then x and x still need to be diagonal from each other, and that's fine. X times x is always x squared equals, do 9 times 25. All right, if you do 9 times 25, that's 225. And again, take your calculator. Do the square root of 225. It's actually a perfect square. It's equal to 15. So you don't have to worry about it. All right. And next one, geometric mean of 16 and 144. Okay, so x squared is equal to, you can do 16 times 144 if you want to, it's 2,304. Square root, take your calculator and check it, the square root of 2,304 is 48. Alright? Alright, now, why are we teaching this? Because there is what's called the altitude theorem. Now I know we've been doing all these theorems lately. You had Pythagorean theorem, exterior angle theorem, you had side, side angle, side. All these theorems are coming out now. Okay, so what this basically says is, if you have an altitude drawn to the hypotenuse of a right triangle, let's talk about altitude. Altitude is the height. So I have this big right triangle right here. A, C, and B. That's a giant right triangle here. But if I draw a height or altitude, which is this line right here, I actually turn this right triangle into two more right triangles. So what's happening is I have a right triangle here, but I also have a right triangle here. You don't have to put the box on both sides, all right? Now, what's happening when you do this is you have three triangles. You have the overall big triangle, ABC. You now have a smaller triangle. I'm going to put an S right here. You have a medium-sized triangle, so you get three triangles. All right, now what's happening is this symbol right here looks like the top part of congruent, but it stands for similar. And when triangles are similar, you can make proportions. So all three of these triangles here, ACD, CBD, and ABC, are all similar to each other because I drew what's called an altitude or a height from the right angle down, all right? Remember, angle C, that was the right angle of the overall big right triangle, okay? So when we do this, certain proportions are going to happen, and that's what we're going to see. All right, so again, this is just an example here. You guys should clearly see three triangles here, all right? You've got the big triangle right here. That's what the L stands for. That's the large one. This is the right angle from the big right triangle. Once we drew the altitude or height, which is that red line right there, that's the altitude, it turned this triangle into two more triangles. You have a small one here. That's what the S stands for. How do I know it's a right triangle? Look at the box. You have a medium one right here. That's what the M stands for. How do I know it's a right triangle? It's got to be a right angle on that side. So you have three right triangles, all right? Here's another one. Box right here, all right? So we have three triangles. Big one, that's the overall, and this is the right angle of the big overall right triangle. You got the medium one, small one, they're both right triangles here, all right? Now, the way this altitude theorem works, you don't really have to worry about all these letters. Here's the way I teach it. You have to have our overall right triangle. This overall right triangle has its angle right there. Now the way I teach it's a little bit different. I call this overall right triangle your property, your land. If it's a bird's eye view of your property, your house is that right angle right there. That is your house. You then have three roads leading away from your house. Today we're only going to focus on this road right here. That's the altitude. That's why it's called the altitude theorem. All right? Now, the way I teach it is whatever street you take to leave your house, when you make the proportion, you list that street twice. In this case, this street is called H Street. So I'm going to list it twice, diagonal from each other. Once you get to the end of this street, the road ends right where I just put my arrow, you have two options. You could take a right on this street or a left on this street. So you could have turned on X Street or Y Street. Whatever street you turn on, you put it right there. Now you're going to have numbers here, so you're not going to have all these letters, and all you do is cross multiply. Nothing changes. Same rule you did in middle school with proportions, you still cross multiply. Okay? All right, so here's what we're talking about. Here's a classic example. I have three right triangles here, but which one is the right angle of the biggest right triangle? That would be this one right here. That I consider to be your home, your house. You have 3 roads leading away from your house, but only one of these streets is labeled, and that's the 4th Street. So whatever street you take, you list it twice, because that would be the same street you come home on too. So I'm going to put 4 and 4 here. Once you get to the end of the road, you have an option. Turn on this street or turn on this street. So I'm going to put a 12 and an X, and now you just go to work. How do you do proportions? 12 times X is 12X. 4 times 4 is 16. How do you get X by itself? Divide by 12. Now you could leave your answer as a decimal or a fraction. It's easiest just to leave it as a fraction. Can you simplify 16 over 12? Doesn't 4 go into 16 4 times, and 4 goes into 12 3 times? Leave it just like that. There's your answer, 4 over 3. That's all you got to tell me. All right? All these problems are the same. Find the overall big right triangle of the biggest one. That's your house. And again, you don't have to keep writing home or house, but that's where you start. Now this one, the only street open is X Street. Whatever street's open, list it twice. All right, because again, if I leave from X Street, eventually I got to come home. I'm going to come back on X Street. I get to the end of the road. Well, I could either turn on 6th Street or turn on 3 Street. There's your proportion. But now, what's X times X? X squared. What's 6 times 3? 18. How do you get rid of a square? You square root it. But, wait a minute, that's not a perfect square, but can I break down 18? I can do 9 and 2, but why do I like 9? I get a pair of 3s. So the same stuff I taught you the first couple weeks of school is still used. So X is equal to, remember, 3 on the outside, single 2 on the inside. There's your answer right there. All right? All right, exact same problem. There's your house. Only street open is X. List them twice. Okay, where can I turn at the end of the street? I could either turn on 10th or 4th Street. All right, basic proportion. X times X is X squared. 10 times 4 is 40. That's not a perfect square, but can we break it down? We can do 4 and 10. Why do I like 4? Pair of 2s. Is 10 going to get me any more pairs? Nope. Single 2, single 5. Where do the singles have to go? Back in the house. Where's the pair of 2s go? Outside. So 2, radical. Now again, 5 and 2 have to go back inside, but that's just 10. So there's your answer right there. All right? All right, last couple ones. Now be careful with this one, because now the triangle's been turned upside down. Where is the house of the overall big right triangle? I see a small, medium, and a large. Is that the house there? No. This is the overall right triangle of the big right triangle. So there's your house. All right, what's the only street that's open? X Street. Whatever street's open, list it twice. Diagonal from each other. All right, what options do you have? You get to the end of the road, you could turn on 3, you could turn on 12. X times X is X squared. 3 times 12 is 36. That's perfect. X equals 6. All right. And this one, that is the house. Only street to go to is 16th Street. So list them twice. Sometimes it's a letter, sometimes it's a number, but the rule doesn't change. Into 16th Street, you could turn on 8th or X. Okay. What's 8 times X? 8X. Now again, you can use your calculator, but 16 times 16 is 256. Divide by 8. X is equal to 32. And the last one, where's the house? That's the house. The overall big right angle of the big right triangle is the house. Only street open is 12, so list them twice. End of the street, what could you turn on? X. Or you could take a right on 9th Street. All right, that's easy. What's 9 times X? 9X. 12 times 12, 144. Divide by 9. X is equal to, if you do 144 divided by 9, 16. And there's your answer right there. All right. All right. I'm going to post a sheet that's going to have some of the problems that look just like this, as well as some problems that just give you two numbers. So again, if I just give you two numbers like 3 and 12, and you got to find the geometric mean, set it up like that. That'd be x squared equals 36, square root both sides, x equals 6. So I'm going to give you problems that look like this, problems that look just like that.